Day 258 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 22, generate parentheses. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. So let's get into it. Question says, given given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So it's pretty self-explanatory, but let's break it down by looking at example one. In example one, we have the input 3. That means we have to find all the combinations that we can create of well-formed parentheses with 3 parentheses, right? And these parentheses right here, this equals one set of parentheses. When we say 3 parentheses, we mean 3 of these, right? Not just, excuse me, y'all. That's 3 parentheses, not just this. Oh, sorry, y'all. Not just this. Well, yeah, not just like this. So this is not what they mean when they say this right here is not what they mean when they say 3 parentheses. They mean this when they say 3 parentheses. And we want to find all of the combinations where they will still be a valid use of parentheses, right? We could do it like this and we could wrap the 3 parentheses inside of each other, or we could do it like this. We could put 2 parentheses inside of bigger parentheses like it did here. We could do it like this where we put one set of parentheses in between the other parentheses and we do the last one on the side, or we could do parentheses on the left side and the ones on the right side, put 2 sets of parentheses inside of each other, or we could just put the 3 sets of parentheses right next to each other like we did up here, right? So that's what they mean by all combinations of well-formed parentheses. The parentheses have to make sense, right? Like, so if we did it like this, say we had it like this, that wouldn't necessarily, say we did it like this and we just put a parenthesis in here. This wouldn't make sense, right? Because you can't just put half a parenthesis inside of 2 other parentheses. They have to be together, has to be whole like this, right? So that's what they mean by well-formed parentheses. That parentheses have to make sense. They can't just be, you can't just open up one parenthesis and close it wherever you want. It has to be closed properly, and we want to be able to find how many combinations we can do like that. So let's look at example 2, where it's just one parenthesis, and in that case, the output would just be one parenthesis because that's the only parenthesis. Another thing to keep in mind is we're putting these parentheses in as an array of strings. So when we return the output, we need to return the parentheses as an array of strings as well. So now that we understand the question, y'all, let's get into the fun part. The actual code is not that difficult, y'all. We'll be able to get through it fairly easy, I hope. So let's get into it, right? But before we get into the solution, y'all, if you need any new Apple AirPods, do not forget to go ahead and check out that link in the description, and go ahead and get you some. Then after you do that, don't forget to like, comment, and subscribe. Now, let's get into it, y'all. So first thing we need to do is we need to create a stack to hold the current sequence of parentheses being formed. So in order to do that, we're just going to declare a variable. We can call that stack. We're going to say var stack : and that's going to be an array of strings. Excuse me, y'all, an array of string. Then we're going to come outside like that, and we're just going to say boom, just like that. Next, we need to create our result array, which will store all the valid combinations that we come up with. So in order to do that, we could just declare a variable, say var res : it's going to be an array of string as well, and we can initialize that with a blank array as well. Now it's time to create our helper function, which will help us with the backtracking. So in order to do that, we are going to say func. This is going to be inside the main function, y'all. So this function is still inside the main function, so that's important to remember. We're going to say func backtrack, open up the parentheses. We're going to say underscore open : that's going to be an integer. Then we're going to say underscore close : and that's going to be an integer as well. Then we're going to come outside of those parentheses, and we are going to open up the brackets, and let's get started on this backtracking helper function. So the first thing we need to do is we need to create a base case if the number of open and closed parentheses used is equal to n. That means we have found a valid combination, and then we need to combine that stack into a single string and add it to the result array, right? Because if n equals 3 and the number of open and closed parentheses equals 3, that means we found our valid combination. So let's get into it. So the first thing we're going to do, we're going to say if open equals close, we're going to say and, two and signs, and close equals n, equals n, then what we are going to do is we're going to open up the brackets, and we're going to say res.append, open up the parentheses, stack dot joined, and put the parentheses right there like so. Then we're going to come underneath that, and we're just going to say return. Now, if the number of open parentheses used is less than n, then we can add the open parentheses, right, to the stack. Then we're going to have to recursively backtrack with one or more open parentheses, and then we're going to have to remove the last parentheses to try other combinations if that doesn't work. So in order to do that, we are going to just come outside of this if statement, and we are going to say if open is greater than n, we're going to open up the brackets, and we are going to say, first we need to add an open parenthesis to the stack, so we're going to say stack dot append, open the parentheses, then we're going to say open plus 1 comma close, just like that. Oh, excuse me, no, sorry y'all, we're not moving too fast. We're going to say stack dot append, and for this we're just appending the parentheses, so we could say open up the parentheses, open up the quotation marks, and then we just append it like that. Now we need to recursively call backtrack with one or more open parentheses. So in order to do that, now we're going to say backtrack, open up the parentheses, and now we're going to say open plus 1 comma close, just like that. And now we need to remove the last set of the last parenthesis to try other combinations. So in order to do that, we're just going to say stack dot remove last parentheses, just like that. Now we need to see if the number of closed parentheses used is less than the number of open parentheses, and we can add a closed parentheses if so, right? So in order to do that, we come outside of that if statement, and we're going to start a new if statement, and we're going to say if close is less than open, meaning we have more open parentheses. This is an example of an open parenthesis, and this is an example of a closed parenthesis. So if we have more open parentheses than closed parentheses, that lets us know we need to append some closed parentheses, right? So in order to do that, we're just going to open up the bracket. We're going to come down here. We're going to say stack dot append, open up the parentheses, open up the quotation marks, and put one of the closed parentheses inside of that like that. Then we need to recursively call backtrack with one or more parentheses, right? So once again, the function right here that we're working with is called backtrack. That's where the recursion comes in. So we're going to say backtrack. Then this time we're going to say open comma close plus 1. Where up here we said for the open, we said open plus 1 comma close. This time we're saying open comma close plus 1. And then we need to backtrack and remove the last parenthesis to try other combinations again. So once again, we just come down here and we say stack dot remove last, just like that. Now we need to start the backtracking process. When we start the backtracking process, we need to make sure we start with 0 open and 0 closed parentheses. So when we do that, we're going to do that outside of this function. So this is really coming back to when this is just when we're just getting started, right? So we're going to say backtrack, open up the parentheses. We're going to say 0, comma 0. And then we still need to return the list of all the valid combinations. So we're just going to come down here and we're going to say return res, just like that. Because remember, res is how we're returning our result. So let's run it. Make sure it runs like it's supposed to. Let's see it's accepted. So let's submit it. Make sure it stays accepted after we submit it, because we all know how this LeetCode stuff can get. Ooh, look at that, y'all. 1 millisecond beat 45.40% of users with Swift, y'all. Don't worry about those numbers right now. Right now, we just want to be able to get to a point where we can solve any question that is presented to us with a solution that we can understand, right? And I feel like this is a good solution for that, and we'll be able to apply the knowledge that we learn from this solution into further solutions as we go further down our LeetCode journey, y'all. So make sure y'all understand this solution and get one more look at it, read it, learn it, love it, before we leave. Get one more look at the solution, y'all. Make sure you understand it, internalize it, and understand whatever it is that's going on, so that you can use this solution, or not solution, but you can learn the things that you learn from this solution on future problems. Now, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.